Our next chapter and the last one in S4 is the one that is called lines and planes in 3D. So here the learning outcomes are very clear. Applies Pythagoras theorem, so someone should be able to apply Pythagoras theorem. Finds the angle between the line and the plane, and finds the angle between two planes. So when we are setting an activity, but by this chapter you can always set one OI, because you can set an OI that captures all the three learning outcomes. So the competence is the learner understands and applies lines and planes in 3 dimensions, solve problems. So this is the problem we have. So as you see, you can by the pause the video and first try it out. So it says, in your community, they plan to construct a rectangular pyramid as a monument. They want you to help them get the diagonal of the base, the height of that pyramid, then the angle between this and the base. So let us start by getting the angle. Now you see in the 3D, this one looks like the base looks like a rhombus, but it's rectangular. Just that you have to do it so that you can visualize it. So if I can pick out that rectangle, the rectangle ADCB, it's going to be like this. So if I'm to pick out this rectangle here, it's going to be something like this. This is my A, this is my B, C, and D. So this is 12 meters. And this is 16 meters. So they want us to get the length of this diagonal here. Or you can get that one, whatever. Anything is going to work. But as you see there, we are just going to apply the Pythagoras theorem. What do we say? Pythagoras says that dB squared will be equal to dA squared plus AB squared, which will be our dA is 16. So meaning my dB now, to get dB now, I'll get the square root of 16 squared plus 12 squared. So my dB will be 20. To be 20 meters. So that's my dB. So the length of this diagonal. And want me also to get now the height of the pyramid. Now it's that the height of the pyramid, I'm going to use, remember, this is our V. So I'm going to use the triangle VOB. But you know that at O here, when I have my O, it means that O is in the center, so meaning it's going to divide this line into 2. So if I'm using now, using triangle VOB, now I'm going to extract out this triangle VOB. Then I put it here, VOB. It's my triangle now, VOB. Remember, our OB is half of dB, so this will be 10 meters. Then we have this VB as 26 meters. So I want now this height. So clear the Pythagoras still, VO squared when you substitute, sorry, squared. So that my VO will be the square root of 26 squared minus 10 squared. You take this side and after, you get the square root both sides. So here our VO equals to 24 meters. So this is the height. So then you reply and respond to the question. the height of the pyramid is 26 meters. Then they told us also to get the angle between A, V, B and the base. So you can extract it out clearly. Still, by the way, okay. So now you see, if I want to get the angle between the base and this one, I'm just going to get the angle between this line and that one there. I don't know if you see that. Anyway, let me first extract it here out. So now, remember this is my D, A, B, C. This is my V. What I'm going to do, I'm going to get just, because I think you can able to see that. It's that the angle between this and this, between this and the base, because I can get this and I have this already. So now it means that if I'm to extract out this triangle here, let me call this one M. So I say using VOM. If I'm to use VOM and I put it here, it's going to be something like this. VOM. Remember, M is just the midpoint of AB. Now, you see that OM is halfway. When you look here, my OM is half of this 16. So meaning my OM is just going to be 8 meters, but I have a height already as 24 meters. So I want this angle theta. So this is the angle you are looking for, the angle theta between this pyramid, between this slanting side and then the base. So clearly from there, if I have this, you can see that I have the opposite and adjacent. Clear there, you are just going to use tan. So you can able to see that now my tan theta is equal to the opposite over adjacent. So my theta will be, this is 3, tan inverse of 3. Then your theta will be 71.565. But we said in angles we don't give to any decimal place, because when you go to your protractor you can't read the decimal point on the protractor, so you give the nearest angle. So the nearest angle here, we just round off, will be 72 degrees. So that will be the angle between the base. So now you come and reply also, so you come and respond that the angle between base and AVB is 72 degrees. So learn that in new curriculum. We don't give angles in the decimal points. We just round off to the nearest angle. Get that? That's it. Wish you the best. So that's our summary for the all activities of integration. I've done activity of integration for senior 1, senior 2, senior 3, senior 4. If you want to see this topic in details, please visit the playlist. You'll see everything about 3D. They are there detailed and everything. You can also go do revision for activity of integration from senior 1 up to senior 4 before you go for your paper. That's it from me. I wish you the best.